All right, chapter 10, sections 1 and 2. So 64 to the 1/2 power, that's just the same thing as the square root of 64. So where's the 2 go? In the index. Where's the 1 go? Right there. So really it's just the square root of 64, which is just 8. This, then, therefore, is just the cubic root of 64, which is just 4. This right here, we're going to do the negative last. The danger in that is you might forget. So think of 36 to the 1/2 power first, which is just the square root of 36, which is 6. Then you got that negative still there, so that would be 1/6. Same thing here, we're just going to ignore the negative, so that would be the 5th root of 243. Now, if you need to take some time and check this, that equals 3. So because 3 times 3 times 3 times 3 5 times would be 243. But there's a negative 1 there, so that'd be 1/3. This one is the square root of 9. We're going to do that first because that's what was taught in class. It's just easier, which is 3. And now we're going to cube it, which is 27. Same thing here. We're going to take the cubic root of 8 first, which is 2. Then we're going to square it, so that's 4. Same thing, 4th root of 81, don't say 9, because you're used to seeing the square root of 9. That's the 4th root of 81, which is 3. And 3 cubed would be 27. I'm going to ignore the negative for last. So I'm going to take the square root of 49 first, which is 7. 7 cubed is 343, but there's a negative power there. That's 1 over 343. Whenever they give you decimals, understand that the previous 8 problems were fractions, and that's what we understand. So we're going to convert this to a fraction. So 9/16 to the negative, see 1.5 is 1.5. If we turn that into that mixed number into an improper fraction, it'd be negative 3/2. Now I'm actually going to do this first because this is a fraction. It just makes sense to flip it right now. And then we're to the 3/2 power. So what I'm going to do is obey that first. So it's the square root of 16/9, which is 4/3. And then we just have to cube it all. 4 cubed is 64. 3 cubed is 27. This one is asking you to remember the rule. When you raise a power to a power, you multiply. So that'd be 64 to the negative 1, which is just 1 over 64. This one, if I raise a power to a power, multiply. So negative 2/3 times 3 over 1, these would just cancel. So that'd be negative 2. So really this problem turns into 5 to the negative 2 power. What I'm going to concentrate on is just 5 squared, which is 25. But then I have a negative that's lingering, so I got to put it where it ain't, which is 25. This is a PEMDAS special, because if you take that 2 and you distribute it here and distribute it here, you're screwing it up. According to PEMDAS, we got to clean everything up inside here first. So this is just the square root of 4, which is 2. This is just the square root of 9, which is 3. So 2 plus 3 is 5, so we get 5 squared, which is 25. Same thing here. Do not distribute that power to here or to here. So why could we here? Well, there's just one term here. Here we have 2 terms separated by subtraction. So we got to figure out what this is first, and this is just the cubic root of 27, which is 3, but then we got to square it, which is 9. This is just the cubic root of 27, which is 3. So 9 right here minus 3 is 6. And now we've got that cubed. 6 cubed is 216. So number 14 is asking you to remember this rule. When the bases are the same and you're multiplying, you add the exponents. Notice the base does not change. So don't you dare go 3 times 3 is 9. If you do that, you're off the rails. So the base doesn't change. The rule wants you to recognize you have common bases and you're multiplying, so you add the exponents. The square root of 2 plus the square root of 2 is 2 square root of 2. Now you could leave it there, but if you cover up the square root of 2, you have a 3 squared sitting there, so you could write it like this, or you could write it like this, but this is the one Algebra 2 wants. This one right here, we got a power to a power, but this is oil, that's water, so you can't really multiply them, so we're going to write it 2 square root of 2. And it's the same thing as the previous problem. You can write it as 9 to the square root of 2 power. Okay, next one. A little interruption there. Had a visitor, dog didn't like it. When you raise a power to a power, you multiply. Square root of 3 times the square root of 3. The roots fly off, so it's 3 cubed. And that is 27. Now, the way I taught this one in class, division, is kind of like this. Where is it warmer? Upstairs. By how many degrees? 5. We're going to stick with that program with this problem, because we're going to say, where is it warmer? Well, if this is the square root of 2 plus 2, and this is the square root of 2 minus 2, we can see degrees-wise, these cancel. So if it's 2 below, downstairs, 2 above, upstairs, where is it warmer? Upstairs. By how many degrees? 4. Now you could leave your answer there, or figure out that 2 times 2 times 2 is 4 times 4, which is just 16. This one right here is just kind of a weird problem. It's asking you to go, okay, I remember my rules. When you raise a power to power, you multiply, so it's 7 to the 2 pi. You could leave your answer there. It's acceptable, but Algebra 2 is going to want you to understand that you got to cover up the pi. 7 squared is 49 to the pi power. Either of these is fine, but this is the one that they're looking for. This one, remember, we take the radicand, slide it over, take the power of the radicand, which is 6 pi, put it over the index, which is 3, reduce that, we'd get 5 to the 2 pi power. You could leave it there, but Algebra 2 wants you to see this. 5 squared is 25 to the pi power. This is what they want. Number 20. Number 20, we got to know what to do first. This should jump out at you as something that can break down. So the square root of 8 is actually the square root of 4 and the square root of 2, which is 2 square root of 2. So if I just concentrate on the numerator right now and just ignore this in the denominator, I'm going to say, hey, the bases are the same and I'm multiplying, so I add the exponents. Oh, this is supposed to be a 2. Okay, so I got to add this to this. Well, 2 square root of 2 plus 1 square root of 2 is 3 square root of 2, and if that's over its own self, what's anything divided by itself? Well, that would be 1. This problem, when you raise a power to a power, you multiply. When you square a square root, the roots fly off, so this is the square root of 5 squared, which is just 5. This one, a little challenging, but if you remember the little jingle I taught you in class, if you look at this and you think 8 times 2 is 16, you're not thinking of this properly, because this is not really 8. Remember, 8 is 8 to the first power. This is 8 to the 1.2 power. So this is where I taught you common bases, happy places. So we got an 8 and a 2. And what I taught in class was 99.9% of the time you can just take the big one and make it match this base. So that's, I'm going to turn that 8 into 2 cubed. And that's 1.2, and now I have a power to a power, so I multiply. So I get 2 to the 3.6, and then this one is 2 to the negative 3.6. And notice, when the bases are the same and you're multiplying, you add the exponents. What's 3.6 plus negative 3.6? That's 0. So I get 2 to the 0 power. And what do we learn? Anything to the 0 power is 1. That's it.